The broadcast is now starting. All attendees are in listen-only mode.
Hi, welcome to the New Eagle Electric Vehicle Systems Design webinar. Today we're going to be talking about supervisory control and components. So we're going to go ahead and get started right here. As many of you know, there is a large push for electrification today in our industry, and so I wanted to be able to share a little bit of New Eagle's expertise in vehicle electronics integration and powertrain control development. So let's go ahead and dive right in. Today I'm going to give a little overview of our company, just what we do, especially within the electric vehicle industry, and then I'll talk some more specifically about our drivetrain control solutions for electric vehicle and hybrid solutions. If you have any questions throughout the webinar, on this GoToWebinar, there is a panel for questions, and if you go ahead and type them out, we can answer them throughout, or we can answer them at the end, whichever you prefer. And so we'll go ahead and jump right in. So New Eagle, we're located in Michigan, in Ann Arbor, here in the U.S., and we provide control system solutions to solve and fulfill your automotive and industrial problems and requirements. We're an engineering group, and as you can see, we have a website that you can go to. I'll have the link available at the end. It's neweagle.net, and so you can gather more information towards the end, and we'll have that available for you. So let me talk a little bit about what we do as a controls partner. We create mechatronic control system solutions, and we work in the controls and mechanical and electrical domains for EV development. So that would include development of the software for characterizing and driving mechanical and electrical systems, and also, as I mentioned, with our expertise, we do integration of electrical and powertrain components. And the real question that we try to answer in all of our development is, what are the problems that you have when integrating? So obviously the first one is, how are you going to integrate a drivetrain? So you need like your inverter and your motor, but then some of the other peripherals are not easily, not always considered, such as like if you have your instrument panel cluster, the data that's shown on there is not necessarily going to be the same as what you would see in a gasoline vehicle. And so one of the questions would be, like, if you don't have an engine, what components may be affected? So that's where we come in as an integrator, and then also we do supplies to bring it back to a full circle as a controls partner. We serve a large variety of different industries, both on and off highway, mobile and stationary, and we're one of the largest suppliers for components for EV vehicles, which can range from the actual powertrain components, like inverters and motors, down to things like embedded displays and calibration tools. So, and then just to show you what else we do, we offer electric vehicle and hybrid software templates, and then we actually use model-based software to do all of our development, and this is to help reduce the time, the cost, and the risk that takes place in the development life cycle. And so, our abilities are to be able to take a concept all the way through our rapid prototyping process and bring a product out into production and be able to service it. And we also provide an engineering team with support as needed. So let's go ahead and take a look at some of the EV and hybrid solutions. So here's a general overview. We're going to take a look at some of our integration tools, and then we'll go over some of the considerations of the actual EV Supervisor. This is the Supervisor is the software that we use to control the whole vehicle, sometimes called the powertrain control module or vehicle control module, vehicle integration control module. Depends on the application, but this is what our EV Supervisor does, and we'll talk a little bit about some of our hardware offerings and a little bit about engineering support. So with our integration tools, we use a variety of tools. I'm here to introduce a development tool chain called Raptor, but we also use Woodward's Motorhawk control tool chain, which a lot of our other customers use. And you'll see that there are a lot of similarities and a lot of the same principles used throughout this whole process. And so we take it from the development process, or from our development tool. You can see that this extends through most of the life cycle for development. And so you can do all of your rapid prototyping, all of your simulations, all done within Raptor Dev, which lies on top of MATLAB's Simulink. So we take advantage of model-based development to design and implement all of our controls. We also use Raptor Cal and service in order to do calibrations and servicing for vehicles, and this is after we have done some of our simulations on the computer or on our PC. Then we're able to take it onto the controller and eventually onto a vehicle and be able to calibrate. We also, some of our other tools include Raptor CAN, which gives us data logging abilities and also the ability to reverse engineer some CAN networks. And this is very useful for custom applications, especially if we're using proprietary CAN networks. And so this is a very useful tool that we can give you more information on later on in its use. And then we also offer Raptor tests and telematics. For Raptor tests gives us the ability to do regression testing, and it can be used for end-of-line testing to ensure that a controller meets all the requirements and specifications before it's released. And then telematics for remote data collection and fleet management. So I mentioned our Raptor Dev toolchain, and in the Raptor toolchain, the idea is to take Raptor Dev and use it with an application engineer that would create a model. And with the Raptor build engine, we are able to build all the executable files and source files necessary to flash directly onto a controller, which will help reduce the development lifetime, so that we can do rapid development, and it also reduces the risk of miscommunications among a very large team, where there's more than application engineers and the software team that might miscommunicate certain ideas within the code. And so let's talk about some of the EV Supervisor. And so the EV Supervisor, the main objective for it is to to manage all the vehicle and torque security functions. And so that would be, managing the drivetrain, but it also does peripheral. It also manages peripheral components. So it can also do control for like AC and heating systems, for lamps, and this is a variety of different inputs that the controller might receive, and so then it can take those and actuate the proper components. But it also is in addition, it's used to manage the high voltage startup and shutdown functions, which require proper timing for a safe startup and shutdown. And this is critical, to ensure that that you have a safe system, and to ensure that you don't damage any components. So in general, what we do in our model architecture is we divide our controls up into sensors and actuators and controls, and we're able to use all that information to also perform diagnostics. And so let's go ahead and take a look at some of the considerations within our software inputs. We use a standardized library that includes adjustable software filters and debounce for a variety of inputs. You can also make the characterization calibratable such that you can take a linear device or a nonlinear device and be able to characterize it. We also want to be able to account for any open or short faults, and be able to take designated actions if you do detect a fault. Say, preparing a default value if a sensor were to go out of range. And then also we want to be able to account for pull-up and pull-down type of inputs, and so we keep that in mind for software with our software configurability. With our CAN interface, we use a variety of CAN tools to develop, reverse engineer, and integrate the CAN interface with different components on the vehicle. We've worked with a variety of proprietary protocols, but also with a variety of more openly used ones, like J1939. And that's something that you have to consider also, because especially with hybrid solutions, if you have, say, an engine, if you're running an internal combustion engine, in the application also you need to be able to communicate all the appropriate variables between the ECM and the electric vehicle, or the electric portion of the supervisory control. And we've also integrated a few other serial protocols, such as like J1587. That's like an older one, and J1708. Those are older protocols, but those are things to consider as well in your hybrid solutions. However, the main CAN interface that we use is, or the main serial interface we use is CAN, which has kind of become the de facto standard for communicating among the electronic components within a vehicle. And you'll find that almost all EV components, like your traction inverters and chargers and battery management systems, use CAN for their means of communication. And in our software, some things that we have to be able to consider as well is CAN timeouts and protocols that may indicate out of range values and validity. So those are things that we have to be able to manage within our software and take appropriate actions. Here I'm also going to touch a little bit on the startup and shutdown sequence. In our software, we have a template for a startup and shutdown sequence. This accounts for enabling diagnostics within the controllers for inputs and outputs, and also it accounts for the high voltage startup and shutdown to ensure that the battery and inverter and all other high voltage components are initialized properly. And so that's a very critical part of our supervisory control, is to ensure the safety of the system and to ensure that you don't damage any parts, especially with high voltage components. And the neat part about this also is that we do offer the software as a template as well. And so if your system were to require additional startup or shutdown parameters, that is something that you can easily integrate into your system and to account for that. So that's another positive effect with using our Raptor tool chain. So with torque management, some of the basics around it is we look at the driver demand, but also we use a limiter within there. We have a lot of complex controls to determine the battery power limitations and inverter or motor power limitations, say from like heat, and we want to be able to limit the torque requests to ensure that the components are within their operating power ranges. And also we want to be able to account for drivability. So we have software that will account and tune a tunable way of ensuring driver comfort. And so let's keep on moving to our diagnostics. Some of the things that we also have to consider, not only with diagnostics or with internal diagnostics, is making sure that the components are operating correctly, and also that the ECU is operating correctly as well. Some of the things that we can gather is determining if internally calculated variables are within certain ranges, or making sure that that nothing is faulted. We also can detect, say, that if like your CAN wires got open or shorted, that the controller can detect it. Same with CAN timeouts and different checksums. We have ways of ensuring that that the data that we are receiving is valid, and ensuring that it is calculated appropriately. And also, as I had mentioned before, different inputs and outputs, we perform diagnostics on those peripheral items to make sure that there are no faults, like open or short to battery kind of deal. So let me talk a little bit about some of our hardware offerings. So we have a variety of hardware that's available, and it ranges very, very widely, from controllers to embedded displays to powertrain components and other peripherals. And so one of the best ways that they can get information about all this stuff is to go on our Wiki and our website. And so I'm going to go ahead and pull that up real quick. I have some of this pulled up, and if you just for future reference, is if you want to find out more information, of course, please feel free to contact us. But in addition, you can see that on our website you're able to access our wiki through here to find out more about our EV and hybrid systems. So here we have some case studies and a white paper, and also if you want to look specifically at our components, there's a link right here, which I already have open, and you can take a look and see some of the options that we have with regards to our EV components. These show some of the core components that you require, such as the controller itself. We have motors and inverters for traction. A DC to DC converter is necessary to take high voltage, take your high voltage and bump it down to a low voltage setting for all of your auxiliary input or auxiliary components. We also offer battery management systems to manage like temperatures and determining the battery current and power limitations. We also offer some displays for looking at the variety of parameters within the controller. Also a variety of power distribution boxes or devices, and some of them are used specifically for low voltage, and some of them are used specifically for high voltage contacts. And then also some other necessary components that you might need for your EV application. So let's go over just a little bit about our engineering support. We have an experienced team that can help develop your application, and so we try to take it through the whole development life cycle. We do have a startup kit that we can use and that you can purchase, and it's used for it's a software template, and depending on what you purchase, you can either get a controller by itself with the software on there, and you can integrate all the components onto there, or you can take the software template and adjust different parameters to customize it and use it as your own. Use it for your very own specific application. And we have a very flexible engineering team that can work with a variety of things. So if you need to work with just the software aspect with the engineering team, then we have that capability. Or if you need more specific integration needs for like choosing and sizing components, selecting certain hardware, or have more specific questions about other aspects of the software, then we can also accommodate for that. So as just as a summary, we develop the tools and products and support that can help you to get to production quickly and efficiently for your EV systems. And so we try to take everything through the full development life cycle, and try to prepare you and have the tools available for you to do all this. And so with that said, if there are any questions out there, we will go ahead and answer them. You should have a tab that you can ask questions on, and we'll go ahead and pause for the moment and see if there are any questions. So I'm going to go ahead. We have a couple questions here. I'm going to introduce one of our engineers, Chris, and he's going to help answer some of these questions. So, Chris online.
Hi, as David said, my name is Chris. I'm an application engineer, and I work with David on many of these EV Supervisor projects. First question we have today. When you pick which inverter you're using in the Motorhawk calibration, does it automatically load the startup sequence for pre-charge timing for that inverter? And the answer to that is no. So the EV Supervisor software allows you to choose which type of inverter you're working with. Currently, the software is pre-configured to work with UQM inverters, RMS inverters, and even Sevcon inverters. So there's a number of different inverters whose CAN protocols are already built into the EV Supervisor software, and users simply just have to specify which inverter they're working with in the MotoTune calibration. The startup sequence pre-charge timing that Pierce is referring to as a separate calibration that is a single calibration for all different types of, for any type of inverter that you use. So Pierce, please let me know if I've answered your question or if I need to follow up. Second question we have from Daniel Dugan, what electric motors do you currently integrate with? Well, I think the more relevant question is which inverters do we integrate with, because the inverters directly communicate with our EV Supervisor hardware and software over the CAN bus rather than the electric motors directly. And I've kind of already partially answered this question. We integrate with UQM inverters, RMS inverters, Sevcon inverters, Parker inverters, and John Deere inverters, which are also known as Phoenix Drive inverters. And what I mean when I say integrate is that we have the CAN protocols for these inverters already programmed into our software. So you never have to worry about trying to understand the CAN protocol for these components. All of the handshaking and communication is taken care of under the covers in the EV Supervisor software. You simply have to choose which inverter you're working with. Next question, what type of charging system or chargers do you offer? I'm going to direct David to go back to the website and then open up the neweagle.net website and then open up the EV Supervisor white paper. Scroll down. So this EV Supervisor white paper that David's pulling up, it really goes into detail as to how the EV Supervisor helps you develop software for your system, for an EV system. And in that paper, we briefly touched on onboard chargers. I don't believe that we sell any onboard chargers ourselves, but we're able to integrate any onboard charger from any manufacturer so long as we're provided the CAN protocol for that charger. Go back to the next question, please.
All right, we have another question. The question is the software, the supervisory software built for, intended for building new vehicles, or can you convert an OEM vehicle? And the answer is, well, you can do both. It's a software template, and so we were able to integrate based off of either any of the known parameters on a specified vehicle, or if it's a new vehicle and you're creating all of your own parameters, then it's a software template that you can adjust both the controls and the I/O for what your requirements are. So it's a very flexible template, and so you can use it for a variety of applications.
Another question that we typically get from customers is, what is the advantage of the EV Supervisor software? And basically it's that it allows developers to begin working with software that's very mature rather than starting to develop software from scratch. This EV Supervisor software that we're discussing today has been used in literally hundreds of very diverse EV applications and has been users have been able to customize it to each application with a great amount of ease just by simply calibrating into the software the types of inverters and other components that they're using. So there's a whole lot of development that's been baked into the software and experience and nuances that basically adds value to the software and is the reason why people choose to use the EV Supervisor template rather than developing the software from scratch.
All right, it looks like that's it for the questions. We're not seeing any others. So thanks again for joining today. We hope that you enjoyed the presentation and found it useful. As I had mentioned before, our website is neweagle.net, and you can feel free to contact us through there or through any other venue items that are listed here. So please feel free to contact us if you have any further questions. So thanks again.